This is an introduction to function composition. Here we're given two functions, f of x and g of x. F of x is x minus 1. G of x is the rational function 1 divided by x minus 1. We're going to combine them in these four manners: f plus g, f minus g, f times g, and then f divided by g. Created a table here to organize our thoughts. F plus g is just these two combined. I'm going to use a lot of scratch work here on the underneath the table. X minus 1 plus 1 over x minus 1. We have a fraction here. X minus 1 plus 1 over x minus 1. We need a common denominator when we combine fractions. So this is just over 1. It is to have a common denominator of 1 and any other number, we've got to multiply that 1 by whatever that denominator is. So this is an x minus 1 on both top and bottom, which gives us, I'm going to save the algebra, x squared minus 2x plus 1 all over x minus 1. But when we add these together, this is the numerator of the left. The numerator of the right stays unchanged to be plus 1. Simplifying this, we're going to have, just adding the 1 and 1 together, we'll have x squared minus 2x plus 2 all divided by x minus 1. Now our domain is, if we don't have any restrictions to the domain, we have an implied domain of all real numbers. Now we can write that a few different ways. All real numbers can be written from negative infinity to positive infinity, or we can write it as a shadow capital R. Now in this case, we have a denominator. We don't want to divide by 0. Bad things happen. Rainbows break and fall from the sky, little puppies die. So we want to avoid dividing by 0. The restriction to our implied domain lies in this denominator. We cannot have x minus 1 cannot be equal to 0. So we're just going to solve for this. So x cannot be equal to 1. Now for the domain here, we can write it a few different ways. We can just write x cannot be equal to 1, or we can use an interval notation that would state that the domain is negative infinity to 1 union with 1 to positive infinity. That's a longer way of writing x cannot be equal to 1. Well, let's look at f minus g. Well, this is going to be the same thing, except that we're subtracting right here. We're going to subtract right here. Nothing changes with the denominator. The only thing that's changing is that numerator, where we have x squared minus 2x, and instead of adding 1 and 1 together, we're going to take 1 minus 1, which is just 0, over x minus 1. The domain stays the same because we have the same denominator, that same restriction of x cannot be equal to 1. F times g. F times g is just x minus 1 times 1 over x minus 1. Well, when we multiply these together, when you multiply fractions, we can rewrite this as a fraction, x minus 1 over 1. You multiply the numerators together, multiply the denominators together. Well, we like multiplying by 1. That just gives us x minus 1 divided by x minus 1, which is 1. So our function is 1 on the function composition of multiplying those together. Now, with this combination, are there any domain restrictions right here? No, there are not. It's just the constant function 1. So this is all real numbers. F divided by g. We have x minus 1 divided by 1 over x minus 1. Well, I don't like dividing fractions like this, so I'm going to rewrite this as x minus 1 as a fraction divided by 1 over x minus 1. I know that when I divide fractions, I'm going to multiply by the reciprocal. So I have x minus 1 times x minus 1 over 1. Well, the 1's really go away since these are no longer rational. They're just x minus 1 times x minus 1. I'm going to put parentheses around here so I don't accidentally multiply negative 1 times x and just combine like terms. So we have to FOIL or distribute or expand this polynomial. This is the same result as what we had in the first two examples. So this is just x squared minus 2x plus 1, where the domain again is all real numbers. We can write that in interval notation as such. Moving over to number 19, two new functions, f plus g. Here we have x and the square root of x plus 1 of that binomial. So the first one, we're taking x plus the square root of x plus 1. We can't combine any terms here, so that's just what it is, x plus the square root of x plus 1. Our implicit domain, or implied domain, is all real numbers, but here we have to be careful with the square root that we don't take the square root of a negative number, meaning that the radicand, what's underneath the radical symbol here, has to be non-negative. So we're going to take x plus 1. It has to be greater than or equal to 0. It can be 0 because the square root of 0 is just 0. It just can't be negative. Subtracting 1 from both sides, we have x is greater than or equal to negative 1. So that's our domain restriction. Now it's all real numbers with the exception of anything that is less than negative 1. So we can include negative 1 and go up to positive infinity. That's one way to write the domain on this. Subtraction. Subtractions, again, like previous, we're just going to change that to a subtraction, which is x minus the square root of x plus 1. Nothing changes with the domain. It is just x has got to be greater than or equal to negative 1. Maybe I should stay consistent and write that in orange. Orange and teal combined anyway. F times g. We're just sandwiching these together. This is x times x plus 1. The only domain restriction is again on the radicand. It can't be, it has to be non-negative. It can't be a negative radicand. And so we're looking at x is greater than or equal to negative 1. Finally, f divided by g. This one is a little more interesting, where we have x divided by the square root of x plus 1. X divided by the square root of x plus 1. Now, it's generally considered bad form to keep a radical in the denominator, so we could rationalize the denominator so it's not in bad form. We're going to multiply that by square root of our conjugate, x. What are we multiplying that by? By the same thing, x plus 1. X plus 1. X plus 1 quantity squared is just x plus 1. And this is x over square root of x plus 1. I was thinking I may have to change a sign in there, but no, this works out just fine for this division, which is equal to x times square root of x plus 1 divided by x plus 1. What domain restrictions do we have? Well, x can't be negative 1. In its simplified version here, x can't be negative 1. But in the numerator, we have this square root. So x has to be greater than or equal to negative 1 as well. So x cannot be negative 1, but it has to be greater than or equal to negative 1. We're going to take the most restrictive measures of x. It's got to be greater than or equal to negative 1, and intersecting with x cannot be equal to -1, which gives us x has to be greater than -1. It cannot be equal to